Good morning, Ovid Middle School 7th graders. We are going to start off our Chapter 2 for Eureka Math, and this is Lesson 7. Unit rate is the constant of proportionality. It sounds like it might be kind of confusing, but we're going to just take your unit rate problems, find a unit rate like we normally would, and we're going to refer to it now as a constant of proportionality. And they're always going to want to abbreviate that with a K. Well, you're going to figure out why they use a K in the next couple lessons as we start building equations using the unit rates. But for now, just think unit rate, constant proportionality, they're the same thing, and they're going to want to represent that with a K. We'll talk about that as we get through our lessons today. All right, so here's our first example. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? Now, why does it matter if the deer population is not constant in a certain area of the national forest? Well, there's a lot of things they have to consider, like what does keep deer in certain areas, whether it's a good food supply, is there cover there, is there water to drink, is there friendly terrain where it's not rocky or no food there. What deer avoid? Areas with no food, areas that don't have water, areas with lots of predators, and so on. And of course, there's the people impact, like what might affect the deer populations. Maybe overhunting, there's not much deer left. Maybe underhunting, there's too many deer in an area. Can pollution be a factor to scare the animals away? Forestry activity over using the lumber. And recreation, is there too many people or ATVs in the area? So there's just a lot of things that conservationists might need to think about when they're trying to find these answers. Now, question B, what's the population density of the deer per square mile? Now, keep in mind from our previous lessons, there's always a y value divided by an x value. So deer per square mile, deer is listed first, that's going to be my y value, and the square miles will be my x values. Now, if I keep dividing these out, 144 divided by 16, 117 divided by 13, 216 divided by 24. I continue to get 9 deer per square mile here. So the unit rate of deer per 1 square mile is 9. There's 9 deer per square mile. Now notice that 9 is going to be the same as my constant of proportionality. So what we used to call unit rate, they're going to keep calling constant of proportionality. It means the same thing, and it's the K value. K is going to be equal to 9. And when we build equations, you'll see why we call that a K. So explain the meaning of that constant proportionality. Well, there's 9 deer per square mile across the entire forest. Now, use that unit rate of deer per square mile, y divided by x. Well, we already did that. We already figured out it was going to be 9, to determine how many deer there are for every 207 square miles. Well, if there's 9 deer in a 1 square mile, and then I'm talking about 207 square miles, that ends up being, after I multiply, 1,863 deer. Use that unit rate to determine the number of square miles in which we'd need to find 486 deer. Well, if there's 486 deer, and there's 9 in each square mile, 486 divided by 9 means that area that we're talking about is 54 square miles. All right, moving on to example 2. Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs the cookies the very next day. Brandon and his mother determined they can fit 36 cookies on 2 cookie sheets. Now, I'm guessing your parents wouldn't be real happy if you told them you need to make a lot of cookies by tomorrow. Because actually, each kid's getting 3 cookies. 96 times 3 means you got to make 288 cookies. Now, that's a lot of cookies. So let's start getting our data here rolling along. For A, is the number of cookies proportional to the number of cookie sheets used? So the number of cookies goes first. Is it proportional to cookie sheets? So the first thing is my y value. The second thing is my x value. And create a table, so we can set up a table and kind of get through some of our work here. But we are going to make 36 cookies on 2 cookie sheets. Now 36 divided by 2 gives you 18 cookies per sheet. Now you could stretch out your table. I kind of just shorten mine up just for time purposes. You keep building your way up. So if there's 2 cookie sheets, make 36, 4 make 72. You're getting 18 cookies per sheet, so 10 gives you 180. You eventually will make your way up to 16 cookie sheets. It's 288 cookies. And if you remember from up in our original kind of work here, you know you're going to need 288, so we get 288 here. Now keep in mind, like my table's just shortened up for time purposes, you would probably want to fill it out a little more complete. The unit rate of y divided by x is 18. And we figured that out earlier in the problem. And of course, that unit rate, or what we call a constant in proportionality, that k value is going to be 18. Remember, that k we'll talk about more when we get to our equations next lesson. What's the meaning of that constant of proportionality? You can fit 18 cookies in each cookie sheet. Now on B, where it says it takes 2 hours to bake 8 sheets of cookies, if Brandon and his mother begin baking at 4 p.m., when will they finish baking the cookies? Well, from 4 to 6 then, that's a 2-hour time span, you get 8 sheets of cookies. And then start all over again from 6 to 8, that's 2 more hours, 8 more sheets, that's 16 total. But keep in mind, way back up here, that is what you're going to need. You're going to need 16 cookie sheetfuls to give that 288, so they're going to be finished at 8 p.m. So you need 16 sheets. All right, just got a little bit more for you here. And we are going to skip on over to page 29 next. So if you're going to slide over to page 29, we have a few problems to look at. For number 1, it says bananas are 59 cents per pound. What's the constant of proportionality, or k? Well, that k value is 59 cents. That's what it is. Didn't have to do any work there. Now we can use that to help solve further questions. So how much will 25 pounds of bananas cost? Well, it's 59 cents for 1 pound. Times that by 25, and you get $14.75. Number 2, the dry cleaning fee for 3 pairs of pants is $18. And of course, we put money first, remember? So what's the constant of proportionality, or what we call the old unit rate? 18 divided by 3 is 6. It's going to be $6 per pair. So my k value is 6. The unit constant proportionality, or what we used to call a unit rate, is 6. So how much will a dry cleaner charge for 11 pairs of pants? Well, if it's $6 for 1 pair of pants to get cleaned, times by 11, and we get $66. All right, then we're jumping down. Last question here, number 4. Each school year, the 7th graders who study life science participate in a special field trip to the city zoo. In 2010, the school paid $1,260 for 84 students to enter the zoo. In 2011, the school paid $1,050 for 70 students to enter the zoo. And in 2012, the school paid $1,395 for 93 students to enter the zoo. Is the price the school pays each year in entrance fees proportional to the number of students entering the zoo? Well, let's take a look. In 2010, you paid that much for that many students, $15 per student. Paid that much for that many students, $15 per student. Paid that much for that many students, $15 per student. So definitely yes, all 3 years, 2010, 2011, 2012, all were ended up being $15 per student after we divided. So yes. Explain why or why not that's a proportional relationship. Well, it's a constant ratio of $15 per student. And identify the constant proportionality. What's that mean? Well, that k value, or our unit rate, is 15, because it's $15 per student. Now, we can answer questions based off of that. What would the school pay if 120 students entered the zoo? Well, if you got 15 kids going to the zoo, $15 per student, and 120 kids going to the zoo, it's going to be $1,800. And then E, how many students would enter the zoo if the school paid $1,425? Well, if you know that you paid that much, divide that by $15 per student. It should tell you how many students you are, and we get 95 students. So once we know that constant proportionality, sometimes we can use multiplication or division to answer further questions off that. All right, thanks for watching, and good luck on your homework assignment that you'll see linked up in Schoology next.